All right, hi folks, this is Larry Mussolino. I'm recording a video for Objective 11 in Math 026. And if you look at Objective 11, you'll notice that most of the topics have to deal with rational exponents. So what is a rational exponent? Well, really what they're talking about here are exponents that are fractions. So of course, we've been working a lot with exponents that are whole numbers like x to the 2, or 5 to the 3, and so on. But we can have examples where the exponent is a fraction. So we want to understand, what does it mean to have a fractional exponent? Well, first let me start off when an exponent happens to be an exponent of 1/2 or 1/3 or 1/4. Well, you might remember in the previous objective, we were talking about square roots and cube roots and so on. Well, it turns out that when you have an exponent to the 1/2, it's really the same as the square root of x. If I have an exponent that's 1/3, it's the same as the cube root of x. And if I have an exponent that's 1/4, it's the same as the 4th root of x. Here's really what's happening is this denominator is moving out in front of the exponent to become the root. So in a square root, I can actually put a 2 out in front. When the denominator is at 3, I can put a 3 out in front as the root. When the denominator is 4, I can put a 4 out in front as the root. All right, so what that means is when I write 16 to the 1/2, it's really the same as the square root of 16. Okay, so the exponent 1/2 is the same as taking the square root of the number, but the square root of 16 is just 4. 8 to the 1/3 is the same as the cube root of 8, but the cube root of 8 is asking you what number times itself 3 times equals 8, so this answer is 2. And then when you see an exponent that's 1/4, that's the same as the 4th root, so that's the 4th root of 256. That's asking you what number times itself 4 times results in the answer 256. Well, if you experiment a little bit, you'll see that the number 4 raised to the 4 equals 256. So that means that the 4th root of 256 takes you back to the answer 4. Okay, so keep in mind that when you see an exponent 1/2, it's the same as a square root. When you see an exponent 1/3, it's the same as a cube root. All right, let me go and do some examples of working with these rational exponents. Now, here's the good news. You probably remember these rules of exponents that says if you have x to an exponent times x to another exponent, you keep the x but add the exponents together. Here's another rule. If you have x to the m being raised to another exponent n, this is the scenario where you multiply the exponents together. These rules are in the reference packet, so if you forget these rules of working with exponents, please keep the reference packet handy. But the good news is these rules apply even if the exponents are fractions. So when I have this example, y to the 3/10 being raised to 8 to the 5, I'm going to use this property that says when you have one exponent being raised to the other, you multiply the exponents together. Even though these are fractions, it doesn't matter. I'm going to use the same rule. So now I'm going to be multiplying fractions. That means multiply straight across. So this is going to be y to the 24/50. But of course, I'd like to be able to simplify these fractions if possible. So how about if I divide top and bottom by 2 to get this fraction in the simplest form? I'm going to end up with y equals 12/25. So that's the answer. So the key to this problem is just recognizing that you have one exponent being raised to another. The rule for that is multiply the exponents together. Folks, I really think it's a good idea to have the reference packet handy when you're working on these examples, because all these properties of exponents are available to you in the reference packet. All right, why don't we do a couple more examples here? All right, well, this one is asking me to multiply two expressions with v's in them. So again, I'm going to go back to that rule we just talked about. It says if you have x to the m times x to the n, the rule for this is add the exponents together. But that's really the setup we have here, because we have the same bases with v. So the rule is add the exponents together. They happen to be the exponents happen to be fractions, but that's okay. All right, well, I want to add these exponents, which means adding fractions, but you probably remember to add fractions, you must have the same denominator. Let me come down here and I'm going to add these exponents together down here. Well, I'm noticing the least common denominator is 14. So I want to change this to have a denominator 14. And I want to change the second fraction to have a denominator 14. The first fraction, I'm going to multiply by 7 over 7, because 7 times 2 on the bottom will get me the 14 I want as the common denominator. On top, 7 times 1 is 7. This back fraction, I'm going to multiply by 2 over 2, because when I multiply 7 times 2 on the bottom, I'm getting this denominator of 14 I want. On the top, I have a 6 times a 2, that's 12. So to add fractions, you keep the denominator as is and add the numbers on top. So this is 19 over 14. So our answer turns out to be v to the 19 over 14. I can't simplify 19 over 14, so this is the final answer on this one. All right, let me do one more example here. It's got to do with, let's do this one, the quotient rule. All right, well, for this one, I just have to think back to the rule for exponents that says when you're dividing the same bases like this, this is where you subtract the exponents. So I'm going to apply that rule to this example. So that means I'm going to subtract the exponents. Well, again, when I go to subtract, I need to have a common denominator. I'm noticing here the least common denominator that I can use is 4. So I'm going to change this first fraction to have a denominator of 4. The second fraction already has a denominator of 4, so I don't have to do anything to change that. First fraction, I'm going to multiply by 2 over 2, because that'll get me the 4 on the bottom. On the top, I'm going to have a 2. So now I can subtract. Keep the denominator as is. 2 subtract 3 is -1. So it looks like I'm ending up with w to the -1/4. But I can't leave my answer like that, because Alex is saying write your answer only with a positive exponent. So I have to remember one more rule. It says if you have x to the negative exponent, what you do is you take this expression and move it down to the bottom of a fraction, and that flips the exponent to be positive. Let me give you an example. Let's say I had x to the -5. To get rid of that negative exponent, you move this x to the -5 down to the bottom of the fraction. That flips the exponent to be a +5. So I'm going to do the same thing with this example. I'm going to move this w to the -4 down to the bottom of the fraction. That's going to flip it to be +4. So the answer here is just 1 over w to the 1/4. All right, let me do a couple more examples. Let's see. Yeah, let's do an example like this, because this one is a little trickier. It's showing me 27 to the exponent 4/3. And what they want me to do is simplify this or work this out to some numeric answer. Okay, so they're giving me 27 to the 4/3. Well, you know, remember a few minutes ago we said if you have x to the 1/3, that's the same as the cube root of x. So imagine we had 27 to the 1/3, for example. Well, that would be the cube root of 27. But the cube root of 27 is asking you what number times itself 3 times equals 27? That answer is 3. So in order to simplify this, what I'd like to be able to do is somehow try to get 27 to the 1/3 out of this expression. Well, here's what I do. I'm going to think of this fraction 4/3 as 1/3 times 4. Right? And 1/3 times 4 is the same as 4/3. So I can rewrite the fraction 4/3 as 1/3 times 4. The reason to do that is I want to kind of separate out this 1/3 exponent so I can make use of this cube root kind of setup. So the way I can think about this is 27 to the 1/3 being raised to the exponent 4. Because remember, when you raise one exponent to another, you multiply exponents. So I can really separate the 27 to the 1/3 inside the parentheses like this. But I know 27 to the 1/3 is the cube root of 27. But the cube root of 27 is 3. So this ends up being 3 to the exponent 4. I can work that out because that's just 3 times itself 4 times. And if you work that out, you get the answer 81. So the answer to this question is 81. So the key part about this is breaking up this fraction 4/3 to be 1/3 times 4. And the reason you want to do that is when you have an exponent of 1/3, you can really think of it as the cube root of that number. All right, with that, why don't we go to an example here that's asking me to work out some other examples. Now, in these examples, one thing you got to be a little careful about is this negative sign here. So let me take the first example. Actually, let me do a different example first. Let me also bring up the explanation so that we can kind of notice that when you have a negative sign in front, you can really think of it as a -1 if you want to. So here's the example I was going to do. If I have negative, let's say 16 to the 1/2. This exponent 1/2 really only applies to the 16. This negative here is kind of separate from the exponent. So really the way I can think about this is negative the square root of 16. Remember, this exponent 1/2 only applies to the 16. So this answer is going to be -4. That's different than if the problem was parenthesis -16 to the 1/2. Now this exponent 1/2 applies to the entire base -16. So this would be the square root of -16. But remember, I can't take the square root of a negative number, so this would be not a real number. But in these examples, the negative sign isn't inside a parenthesis. So when they say -625 to the 1/4, I'm really going to think of this as negative the 4th root of 625. Remember, I can think of this negative sign as being totally separate from the exponent because that negative sign is not inside parentheses, so it's not part of the exponent. All right, well, now I want the 4th root of 625. And if you work that out, you're going to see that works out to be -5 here. All right, let's go down to this example, -216 to the 1/3. Again, the negative sign is not part of the exponent. The exponent is only applying to the 216. So this is going to be negative the cube root of 216. All right, well, the cube root of 216 is asking you what number times itself 3 times is 216. That works out to be 6. So this answer is going to be negative 6. Notice I'm just bringing the negative sign along with me. All right, so for these examples, it was important to recognize that the negative sign was totally in front. And the way they think about it in the explanation is you can almost think of it as a negative 1 in front. Notice the way they put a negative 1 in front of the fourth root. So if that helps to think about a negative 1 in front, you can certainly write it out that way. All right, let me go ahead and do a few more examples. That one we just did. Let me come over to this one, which is powers of powers with negative exponents. All right, well, let me work this out. I'm going to follow order of operations. So order of operations says work out what's inside parentheses first. But I can't really multiply what's inside the parentheses because notice this is an X and this is a Y. So they're two different bases. So I really can't simplify inside the parentheses. But I can use a rule that says if you have A times B to an exponent, you're allowed to take this exponent and let it apply separately to each quantity inside. So I could write this as A to the M times B to the M. So I'm going to do that for our example. I'm going to take this exponent 5 that's out in front and let it multiply each one of the quantities inside. So this is going to be X to the negative 5 over 3 raised to the 5. I'll write it like this, raised to the 5. And then it's going to be Y to the 1/4 raised to the 5. All right, now I'm going to use a property that says when you have one exponent being raised to another, this is where you multiply the exponents together. So I'm going to multiply these exponents together. I'm going to think of this as 5 over 1 to do the multiplication. So it's going to be negative 5 times 5, that's negative 25. And on the bottom of the fraction, 3 times 1 is 3. Let me do the same thing for the Y. Multiply straight across. 1 times 5 is 5 on top. 4 times 1 is 4 on the bottom. All right, so this would be my final answer, except Alex says you can't have negative exponents in your answer. But I remember the property that says if you have a negative exponent, you can move it down to the bottom of a fraction and it'll flip to be a positive exponent. Y to the 5/4 I'm going to leave on top because that has a positive exponent. That's okay. I'm not going to do anything with that. So here's my final answer. Y to the 5/4 over X to the 25/3. All right, let me do one more example here. Let me come to this one. Let's take a look at this one. All right, this one says simplify and write your answers without exponents. All right, so why don't we do the bottom example first, maybe? Let's do this one. This one might be a little easier. So it's telling me 1 over 625 to the exponent 3/4. All right, let me go to one more properties of exponents. And again, this is why it's good to have the reference packet open because there's a lot of properties of exponents. You want to be able to take an expression with exponents and match it up to one of those formulas to, try to simplify. All right, well, I'm noticing here I have a fraction being raised to an exponent. Well, the property says if you have a fraction being raised to an exponent, you could take this exponent and apply it separately to the top and the bottom. So usually you see it written as A to the M over B to the M. Okay, Well, let me work that out in our example. I'm going to take the exponent 3/4 and apply it top and bottom. All right. Let me go to the top. 1 to any exponent always stays as 1. So the number 1 to any exponent always stays as 1. So this answer is just going to be a 1 on top. Let me now work out 625 to the 3/4 on the bottom. Well, you might remember the way we thought about this was break this up and take the fraction 3/4 and write it as 1/4 times 3. Remember, the reason we're doing that is when you have the fractional exponent 1/4, it's the same as the 4th root. All right, I'm going to write this as 625 to the 1/4 raised to the exponent 3. But 625 to the 1/4 is the same as the 4th root of 625. And the 4th root of 625 is asking you what number times itself 4 times results in 625. Well, that answer is 5. So this is 5 to the 3. But 5 to the 3 means 5 times 5 times 5. If I work that out, that's 125. So this denominator we just figured out works out to be 125. So the answer to this one is 1/125. All right, well, let's do this top example. The reason the top example is a little more complicated is it has a negative exponent to it. But I remember how to get rid of a negative exponent. If I have a negative exponent, you just move it down to the denominator and it flips to be a positive exponent. So let me do that. I'm going to move this down to a denominator. It's going to be 1/27 to the 4/3. All right, so let me work out this 27 to the 4/3 separately. Maybe I'll do it over here. Let me erase this here to get a little more room. I'll do it over here. So we want to work out 27 to the 4/3. All right, you remember the strategy here is to take this 4/3 and rewrite it as 1/3 times 4. But anytime you have a multiplication of exponents, you can really think of that as one exponent being raised to the other. So I'm going to write it like that. The 27 to the 1/3 is really the cube root of 27. But the cube root of 27 is 3, so this is going to be 3 to the 4th. And 3 to the 4th, if you work that out, is 81. So on the bottom of this fraction is 81. So the answer to this question is 1/81. All right, folks, hope this is helpful as you're working in Objective 11. Please let me know if you have any questions.